Alright, this video is going to be about solving polynomial equations. First step when you're doing these is always going to be to factor, and then your second step is going to take each of those factors that you found, set them equal to 0 so that way you can solve those. So if we look at example 1, the main thing we're using here is that rule, the a squared minus b squared. Because remember, that can be broken up. I can make that into an a plus b and a minus b. So what we can do here is that, I have x to the fourth minus 1 equals 0. So if I follow my rule here, I'll write it all the way out. We have a plus b times an a minus b. So what we're going to do is we're going to factor this. I need to say, okay, well my a value then is going to be an x squared because it's the square root here. So I'll have an x squared. And my b value is just going to be 1. So x squared will have a plus 1 times an x squared minus 1 equal to 0. Now that I'm here, I can take each of these factors and set them equal to 0. So I have an x squared plus 1 equals 0, and I have an x squared minus 1 equals 0. So from here, what we're going to do is, we still have an x squared, we can factor again. But x squared plus 1, there's nothing that I can square to get a negative number out if it's going to be real. So this one actually has no solution here, so I can actually ignore this one and come over here and say, okay, if this x squared minus 1, that follows our same rule as up above, except for our x value is a instead, but our b is still 1. So it's going to look like an x plus 1 multiplied by an x minus 1 equal to 0. So now take each of these equal to 0. This one is going to end up with x is equal to a negative 1. This other factor would end up with an x is equal to a positive 1. What I like to do when I see these ones, so x to the fourth minus 1 equals 0, if there's only something to a fourth power here, and there's no individual x, what I could do is I could just say, well, I have x to the fourth minus 1 equals 0, add 1 to both sides, x to the fourth is equal to a positive 1 now. Now I can take my fourth root on both sides. Whenever it's an even number, you're going to end up with that plus or minus. So x is equal to a plus or minus 1, which is the same as what we got out over here. If it were an odd, what am I thinking of? Exponent, so let's say I had x cubed, then it would only be one sign. So if this had been a cube and we'd had a 1 here, it would just be 1. If we had negative 1, it would be negative 1. So it keeps the same sign when it's odd. Now for example 2, we have this x on the other side, so we can't solve it using that little trick. What we have to do is we have to take those over to that other side. So if I subtract the 5x over, add that 3 over, our equation is going to look like a 2x squared minus 5x plus 3 equals 0. So now once we're here, we're going to factor. Remember, there's that Xbox method or the t-chart. I'll show the Xbox because I'm guessing that's the one you guys are more familiar with. Xbox here, we would say, okay, I need something that multiplies up to 6, but I need it to add to a negative 5. So that tells me if I can think of some factors of 6 that add to positive 5, I just need to make them both negative then, because a negative times a negative is a positive value. So let's say, okay, a negative 2 times a negative 3. Well, those would add to negative 5 and still multiply to that positive 6. So from here, I showed you factoring by grouping, but there's also that other trick where you use your box method. So you say, hey, I need something that multiplies up to a 2x squared and to a 3 here. And I'm going to break up this negative 5x into a negative 2x and a negative 3x. So negative 2x, negative 3x. With this one, you now go and say, hey, what do they have in common? And write that over to the left, up on the top, and then it's going to give us our two factors for this. So here, a 2x squared and a negative 2x, well, those both have a 2x in common. Down here, a negative 3x and a 3, well, they have that 3 in common. But whenever you see that negative in the front as well, you're going to say that's going to come out, negative 3x here. Or sorry, negative 3 here. Now I look this way and say, hey, what do these two have in common? Well, there's nothing in their constant, so it's just an x. And then here, A negative 2x and a 3, those have nothing in common, but there's still that negative in the front, so negative, but it's a 1. So what we're going to do here is we now have, this is one factor, 2x minus 3, and that's multiplied by that x minus 1. This is all equal to 0. So here, take each of those factors, set it equal to 0, 2x minus 3 equals 0, x minus 1 equals 0. Over here, we'll have a 2x equals 3. Final answer, x is equal to 3 halves. Over here, we just add 1 over, so x equals 1. So these would be our two answers here. Alright, and the last example, 2 root x equals x minus 3. So we see that square root and we're like, things are getting a little wonky, but what I want to do is just the same thing. I'm just going to get this equal to 0 first. So if I take that over, I end up with a 0 is equal to x minus 2 square root x minus 3. And this actually follows the same patterns as what we were factoring over here. 1 is a square. Oh, if I take the square root of x squared, it's x, and then a constant. Well, it's the same pattern here. X, well, the square root of x is square root of x, and then a constant. So it's the same pattern, so I can use my same factoring strategies. I'm going to say, hey, I'm going to use this x box method and say, okay, well, I need something that multiplies to negative 3, but adds to negative 2. Well, it's going to be a negative 3 times a positive 1. Because there's no value in the front, we can go straight to our factors. So we're going to say, okay, we have a x minus 3 times an x plus 1, but instead of x, because this middle term is a square root, these are square roots. So square root of x minus 3 and the square root of x plus 1 equals 0. And the 0 can be on either side. Now, same thing, we take each of these factors and set them equal to 0. So I'm going to have a square root of x minus 3 equal to 0, and a square root of x plus 1 is equal to 0. So here I add the 3 over, we're saying, hey, the square root of x is going to be equal to 3. Well, the square root, if I square both sides, that gets rid of that. X is equal to a 9 then. Now, the square root of x plus 1 equals 0, subtract the 1 over, so we have our square root of x is equal to a negative 1 then, though. But if I think about this, there's no value that I could plug into a square root and get a negative back out. So this has no solution, actually. The reason I can say that is because, hey, think about that graph of a square root. It's actually going to look like this, and there's no value down here. So if there's no values down here, this is not going to have any solution. So our only answer is x equals 9. And if you really want to check that out, say, hey, well, what if I plug a 1 in, because the square root of 1 is technically 1 and negative 1. Well, if I plug 1 back into here, I end up with 2 instead, because square root of 1 plus 1 is 2. That is it for our solving video. Make sure you go through and complete the practice problems. If you have any questions, feel free to contact me.